Today, let's solve a problem from calculus. So we have two functions from real numbers to real numbers. Both of them are positive, and both of them are continuous. So, and if given f of x is less than or equal to a plus the integral from 0 to x, f of t times g of t dt, where a is strictly positive, x is non-negative, then can we show f of x is no larger than a times e to the power of integral 0 to x, g of t dt. And this is a special case of the Bellman-Gronwall inequality in ODE, ordinary differential equations. But luckily for this one, we don't even need any knowledge of ODE or linear algebra. All we need is some differential and differentiation and integration techniques. So here I just observe, I can simply set this integral as h of x, even though it's integration with regard to t, but it's still changing upper bound is x. So h of x from 0 to x, f of t, g of t, dt. Now, quickly we can just work out its derivative. Alright, since it's changing upper bound is x, we just replace t with x everywhere. F of x times g of x. Now, given this condition, f of x is less than this, so I multiply by g of x on both sides. Still the same direction because g of x is positive. So f of x times g of x is no larger than a times g of x plus. Notice this is h of x. H of x times g of x. Right? So I just move this thing to the other side. Right? Then take out g of x, common factor. F of x minus h of x times g of x is less than a times g of x. Right? This is what I have. And now I just multiply both sides. You will see why. I just both sides by e to the you will see why it's negative, right? Because we want to prove this one, right? This inequality. So this negative 0 to x g of t dt, right? So doesn't change direction because e to the power is still positive, right? Less than or equal. Let me put it this way. So less than or equal a times g of x times e to the negative 0 to x g of t dt. Right? Okay. Now the reason I put negative integral is because here if we just observe closely, right? So this is in fact the derivative of something, right? The derivative of, in fact, integral 0 to x f of t g of t dt times e to the negative 0 to x g of t dt. Right? So this is a function of x. This is a function of x. So if we differentiate with respect to x, what can we get? Right? So it's a product of two functions. So derivative of that is simply just differentiate this, keep this. When you differentiate this, notice this is h of x. So f of x times g of x, keep this, e to the gt dt plus. Keep this, differentiate this. Right, so this is just h of x. Right, differentiate this. When you differentiate this, first you keep this. right? Keep this. Then you differentiate the top, right? Notice there's a negative sign coming out. Right? Then you differentiate this integral, so it becomes g of x. Right? So here, common factor is g of x times this exponential. G of x times this exponential. Common factor, right? You take it out. You have f of x minus h of x times g of x times e to the negative 0 to x g of t dt. Right? So this is exactly what I have on the left-hand side. Right? Right? That's the derivative of this thing. Right? Derivative of this thing. Right, since we're talking about derivative, right, then we can immediately just implement integral on both sides. Right? Still maintain direction. Integral with respect to x, maybe. Right? I'll put it. Maybe from 0 to u. Right? Dx. Okay? That's not equal to 0 to u dx. Here I just treat u as a fixed constant for now. Right? Since this is a function with respect to x. So I just say dx. All right, so is this one. Right. Okay, so here we have, like I said, this thing is the antiderivative, because this, right, when you differentiate this, it gives you this. That means this is the antiderivative of this. Right? So when you integrate, you just simply use its antiderivative, then plug in the lower bound and the upper bound. Right? So when you use this use this, plug in lower bound 0. X becomes 0, 0 to 0, 0. Right? You plug u into here, it'll give you this. 0 to u f of t g of t dt. Right? Multiply e to the, like I said, x becomes u. 0 to u g of t dt. Let's learn. Let's take out a out here, right? What's the integral of this times this? If you notice, if you simply differentiate, if you dx e to the negative g of t dt. Right? What's the derivative? Right, you keep this text gt dt, and you differentiate this. Right? There's negative sign coming up, so maybe we can use negative. Right? Negative. Right, negative become positive. Then you differentiate this one, g of x. Right? So it turns out that when you take out 8 here, right? Right, this immediately becomes, you plug 0 in here, because this is n, right? This is the antiderivative of this. This antiderivative of this. Then you plug 0 in x, gives you z, right? e to the 0, the negative 1. Right? Minus negative 1, you plus 1. Right? There's a out here. Then you plug u into here, into x, you get negative e to the negative 0 to u g of t dt. Now, so far we've concluded that this inequality holds, right? Resulting from this inequality, right? As a result of this. Right? Notice that this is in fact h of u, because I let h of x equal to this changing upper bound integral. Now the only difference is that there I have x, here I have u. Right? H of u. Then I multiply both sides by the reciprocal of this thing. Right? Becomes 1. Less than a times this. But this, the reciprocal of this times this will become 1. Right? So I have negative a. Right? Then a times 1, then times reciprocal of that. That is a times e to the positive 0 to u g of t dt. This is what I have. Now here I just move this a over there. Right? Because I think I'm pretty close to the desired result. So a plus this thing. Right? So a plus h of u is less than a times e to the 0 to u g of t dt. Right? And there, my given condition is that f of, if you simply replace x with u, what happens? F of u is less than a plus 0 to u, then h of u, a plus h of u. Right, here, f of u is less than right. This is what we have. Right, so we've just loosened the inequality by using this one, right? That's the given condition. So really, f of u is less than a times e to the integral 0 to u g of t dt. Like I said, the only difference is that here you just replace x with u, right? 0 to u, right? F of u, same thing, right? 0 to u, same thing. Here, maybe replace u with x back, right? F of x is less than a times e to the integral 0 to x g of t dt, right? It's the same thing. Right? Like I said, we first treat u as a constant. Of course, u is greater than 0. There's nothing special about u, right? If it works for u, of course, it works for any x that's greater than 0. Right? That's our desired result.